Okay, so good evening. Our 13th Statistical Saturday Club meet. So we have completed almost 3 months. Now we are moving to some intricate part of probability mass functions and discrete probability distributions. We will give some short introduction to these concepts. So now if you see this diagram, we have completed some around this part. Then we moved to the this part, and now we are approaching to this part. So almost three diagrams we have completed, and now we are moving to the fourth part. So eventually we will move to Python also, but yes, there is much time to go over there. So today we will have some short recap of what we have learned yesterday. Then we will go into the probability mass function. Usually we will call it PMF. So we have introduced this function in last, I think, ninth or 10th week, but we will give some short brief or intuition so that we can move to the discrete probability distributions. We will only cover today, I think, two probability distributions. One is uniform and another one is binomial. So without wasting our much time, we will directly jump into our recap. So last session we have completed these three parts. Almost we are discussing for 3 weeks very intricate concepts called conditional probability, law of total probability, and Bayes theorem. So if you know that the probability of A given B, this is what we were calculating, that if we know that some event has already happened and we want to calculate the probability of another event which is going to happen, in that case we can make use of conditional probability, and there we can achieve this by knowing that probability of A intersection B divided by probability of B. So this is how we will know the probability of A given B. And we have learned about based on that rule of conditional probability, we have derived the law of total probability. So what is law of total probability? It is about the scenario where some events have partitioned our sample space. So this can be our event E1, E2, E3, and E4. Need not to be limited. You can have 10 events, you can have only 2 events, minimum at least 2 events you can have for law of total probability. So the only condition is that they should be mutually exclusive. So there should not be any intersection in event A and event E1 and E2 or E2 and E3. They are not at all having any intersection. So they are mutually exclusive and collectively exhaustive. So there should be the end. So these events cannot be infinitely many events. You can have the collectively they should complete as a sample space. So there is whole sample space has been divided into some parts by the events. Then you can have the another event. Maybe I should change the color. So then you can have this event called A, and the probability of that event can be given. So probability of A in that case, which you don't know, you know the probability of these events, but you don't know probability of this event. In that case, we can use the probability of A E1, A given E1 plus probability of A given E2, and so far until probability of A given E4. Okay, this is what will be the total probability of event A. This is what we have learned, and based on that we have learned the probability, the Bayes theorem. So these two are the fundamentals to go into the Bayes theorem. So what is Bayes theorem? Bayes theorem is also calculating the same in the A and B. Here you can also see the probability of A given B. Just it is making the use of concepts by making some changes or the algebraic manipulation over here. So it can do like probability of A given B is given by probability of B given A into probability of A divided by probability of B. I'm simply not going into this how we have derived it, because last 3 sessions we have did it extensively. Please go and watch those videos for your better understanding. But what is I'm more interested in, not these formulas. Formulas are not important. You can go like this. This is what I have copied from the internet. This image I have copied. So you can go at any point of time, you can go and get the formula in your real life. I'm not talking about the exam. In your real life, you can go anytime and you can get the formula. Maybe I will just stop my webcam so that you can see the Bayes theorem formula. That probability of A given B is equal to probability of B given A into probability of A divided by probability of B. So what I was saying, that I'm not interested in these formulas. You should not remember or not try to mug up. If it is eventually coming in your mind, that's all. That is good thing. But if it is not coming in your mind, no worry. You can go and refer. What is more important, that when we can use this formula. So that's why I will give you some example where hint has been already given, that here you can use the Bayes theorem. So I will not solve this problem. I have not asked even the problem, but this is a sort of practical problem you will see when you go for the development studies. So a student went into a village to study the developmental issues. The student has went down, in case of if you are a student of TDA, that is you have went for your fieldwork segment 1, and you have observed that there are some school dropouts, but out of that school dropouts, 60% school dropouts are because of poverty and 40% school dropout are because of health. If there is no good health, he or she, the student, might be having problems, or that's why dropouts. But majority, so 60% of the school dropouts are only because of poverty of that family. So that family is not able to send their children to the school. So this is what you have come to know. After that, again you have went for the FWS1 or otherwise in that same study, and you have started studying on poverty. So first you have come to know, you were studying about school dropouts, but there you come to know that poverty is major reason for the school dropouts. So you started studying on the poverty, and then you come to know that 40% of total students are poor. Okay, so there is a situation. This is what the data, after you have went, you have did some palm tools, that is participatory learning methods, or you have did some survey, but you come to know this with surety. So now I can pose a question, I can ask a question based on the Bayes theorem, that if you go and meet a boy, I'm not saying about the student or dropout, he is a boy, so maybe a small boy, and you come to know that he is poor because of some proxy indicators like his clothes, house, and other proxy indicators. You come to know that this boy is poor. I can ask that now, what is the probability that he is a school dropout? This is what the problem of Bayes theorem, that you are having some student, and then you are asking the question, something you know, and then you are trying to have some relations between this your information. Mostly it is called as the revising your probabilities based on the posterior information. What is posterior information? Posterior, just after that. So only you are known, first you know this part, the poverty, the dropouts, 60% dropout because of poverty. Then you come to know that the total out of that 40% students are poor. So based on this, sorry, based on this you are trying to calculate the dropout. So this is what the problem of Bayes theorem. If you are interested, you can solve this problem using the Bayes theorem. So main skill here you are required is describing the events. what is the event A and B, because you know this formula, probability of A given B, but in this case, what is my A, what is my B, and how I'm going to calculate the probability. This is what skills are required except the formulas. Okay, so this was covered until the last week, and now we will move in the another arena of the probability distributions, which is somewhat extra than this. So now here I am having a variable, and the variable name is education. So suppose you have went for survey and you are collecting the data, socioeconomic data. So you come across, you have collected the data, so you have made some categories for the education. So you have said that there are some illiterates, primary education, secondary education, higher secondary education, up to graduate level he has learned, postgraduate and doctorate level. Suppose a person comes and tells that I have studied only up to 4th standard, then you might write in your survey as a primary. So now I think Amit, can you answer me that whether this is a random variable or only a variable?
But yeah, now it is only variable. If we take means according to my understanding, when we take according to 100 data, when we take randomly 10 data, this comes under variable, na? Random variable.
Uh, okay. So you said first thing is correct. This is not variable. This is not random variable. This is only variable. But the reason you said why is not correct, because I will just tell you that. What is a random variable? Random, you just misunderstood that random means any value randomly taking. This is partially correct, not correct in what sense you are saying. What I'm saying, see, the random variable should take only qualitative values. Sorry, quantitative values. Random variable should take only quantitative values. Suppose this variable, this is variable because it is taking qualitative values like illiterate, primary, secondary, higher secondary. This is not taking 1, 2, 3, 4 or something 10, 11, 13, 14. Okay, and that's why this is a only variable. So that's what I want to clear for you, that variable can have any values. It can take quantitative values, it can have qualitative values. This is what our statistic first course we have said. We will categorize the values into the qualitative, quantitative, nominal, ordinal scale, discrete, continuous. This part we have did in first session. So what is random variable? Random variable takes only a quantitative variable. So I have given, now I have formed this another formula. Okay. You want to share something, Amit? Is it clear?
Clear, bhaiya, got it now.
Yes. So now here I'm saying two variables with the same name, education and again education. But in this time I have marked, so this is called coding, isn't it? So in the coding
Yes.
I have did mapped this illiterate to 0, primary to 1, secondary to. So if a student is coming or a person is coming and he said that I have studied only up to 7th standard, then I might enter only 2 in my questionnaire data. Got it? So now this
Yes.
becomes my random variable. This is only variable. This is now my random variable. Okay.
Okay, got it.
Up to here, clear. So now these are the possible values. I am not saying that this is my data. This is not my data. How my data would look like? My data can have multiple columns. So here I can have the name and the gender and the education. I will map my gender to 1 and 0 and 1. So 0 for male and 1 for female. So that my data would look like, I will say this is my data. So name is Amit, gender is male, and education is now fifth because you are in postgraduate level. So this is what my data. Okay. Here can be many rows. I can go and collect from data from village or somewhere else. So I can write my again Mayur, again gender male, and my education is about postgraduate. Okay. Or somewhere X person is here, gender is female, and education is doctorate level, and Y person is there who is again female, but education is only graduate level. So this is what my real time data. But in this education column, what can be possible values? These possible values can be from 0 to 6. That's why this becomes my random variable. Clear? Clear, Amit?
Yes, Bhaiya.
Okay. So now we will move to the probability mass function. So now up to here, this was my variable. I have converted into the random variable by mapping these values to 0 to 1 this way. Now I have added one another scenario here. This I have collected this data. Okay. And based on this data or some secondary data, I come to know that in the village which I am going to study or collect the data, there are 25% are literate, 25% are primary education people have, 20% have secondary education, higher secondary education are only 10%, graduate are only 10%, postgraduate are 10%, and doctorate are 0.5%. Now I want to ask you that is this a correct probability mass function or not? What is probability mass function, by the way? It maps the value with probability. If I ask that what is the probability that the person, if I randomly select person as education primary level, in that case you can simply tell that this is a 0.25, isn't it? Because primary means first it's 25, correct? Be attentive, Amit.
Yes, Bhaiya. Yes, yes.
Correct. So now I want to ask that whether it is correct probability mass function or not.
Actually, Bhaiya, I don't know probability mass function means. Uh,
Yes. Okay. So I will tell you that this is not correct probability mass function. Why? That also I will tell you. But before that, I will tell you what is probability mass function. Okay. Suppose you
yes,
take
yes.
suppose you take a coin. Okay. If you toss a coin, what are the possible outcomes?
Head, tail.
So I will write head for H, tails. Correct. In that case, this becomes my variable. Correct.
Mm.
If
Yes.
I tell you only this information, you know that coin is a variable, takes value H and T. Now what I did, I mapped H with 1, tail with 0. So now it became my random variable.
Random variable. Yes.
If you get information, you know that random variable. Now what I did, I will just, yes. So now what I did, I give another information, and you maybe intuition is that the value, this coin random variable takes two value, but what is the probability that it will take value 1?
1/2.
Okay, so 1 by 2. What is probability it will take value 0?
0 also 1/2, na?
1 by 2. If I give you this whole information, it becomes my probability
Probability
mass function.
mass function. Okay, okay. We have random variable and we have to take.
Probability also. So in this case, I have told you this is my values. With what probability it takes value 0? It's 0.25. What probability it takes value? 0. But why this is not valid? Because in probability mass function, you should have this is the probability of taking values. Probability of coin toss. This is actually a function. What is function? Function is something which maps input to the output. Okay. So now how
Yes, sir.
probability mass function is function? Probability that it will take I will say toss, you take toss, is equal to, it has two options, 0 with probability 1 by 2, 1 with the probability 1 by 2. So this is some not nice function like this x square, but you have two values. This is what function. Okay, that's why it is called as a probability mass function. Okay, what is
Okay.
the real, when it is the accurate probability mass function? When the probability of coin, if you add up all the possible values, if it is coming 1, then only it is the probability mass function. Now
Probability mass.
it's right, because see, 1 by 2 plus 1 by 2 is equal to 1. But if you add this, so it is 25 plus 25 plus 25, 75 plus 20 is 95 plus 15. It is coming
Probability R
1.1.
is 0 to 1, na? It will more.
So it is going more than
Mm.
1.1. So that's why this is not valid
Probability mass.
probability mass function. Okay.
Yes,
So
bhai.
now this is the corrected version of the probability mass function. What is probability mass function? Now here if you add, it is 25, 25, 25, 75 plus 15, 90 plus 5, 10. So it is correctly adding up to the 1. Okay. So this is what
Yes.
my variable. This is random variable. This is
Probability
PMF.
mass.
Okay. Please note here, probability mass function is defined for discrete variable, discrete random variable. Okay. This random variable education is taking only 7 values, 0, 1, 2, 3, 4, 5 and 6. It is not taking values like 0.01, 0.0001 or 0.6. If it is taking all the values in between 0 to 6, then you cannot write all the values. Correct?
Yes.
In that case, it becomes continuous
Probability. Continuous
random
random variable.
variable. For continuous random variable, we have another function. It also you can calculate the probability, but that is probability.
Normal distribution also comes under continue, na?
Yes, normal is a normal distribution is a continuous
Continue.
random variable can take.
For
So random density function. Okay, sorry, probability just give me a minute. Probability density function. So for normal distribution, we will say that it is probability density function,
continue.
continuous variable. Like normal distribution is continuous distribution. There are many. Uniform also has some continuous distribution. Okay, one uniform is discrete also. One uniform is continuous also. There are many other such variables, continuous variables which are available. We will now only look at discrete random variables. Okay. So for that,
Yes, bhai.
it is PMF. Now you know how to calculate the PMF. We will see one another slide where you can have some kind of visualization of data and like what is probability available, what is random variable, that sort. So now here you see. Here the example which right now we were discussing, that education, we have now we have removed the variable part. We are only interested in random variable. This is random variable and this is the probability with which it takes the value, and this whole table gives me my, what is this, gives me probability mass function.
Probability mass function.
Okay. So now here I have one small graph also. Are you able to see below?
Yes, bhaiya, yes.
So this is,
Probability education.
yes, it is taking 0 with 0.25. First three are similar, these three. Then it is taking some odd values, 0.10, 0.5, 0.5. Okay. This is my first
Yes,
graph. You just look at the graph. Okay. Then I'm having another random variable, the die. I am rolling a die and I'm getting output 1, 2, 3, 4, 5, 6. These are the only 6 outcomes, correct? What is the probability? It is 1 by 6. So approximately 1.67. If I add all these values, it is 1 by 6 plus 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 1 by 6. It is coming 1. So it is correct random variable. Okay. But if I graph it, you can see that it is only a straight line. There is no variation. All probability are on same line. It is like okay. So there is one straight line here. I will not draw because my line is not coming straight. Okay. Then another random variable I'm having. This is the hypothetical data that I went for a survey and I collected the age. Okay. So age I have taken from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 45, 50 to 60, 60 to 70. Like that, I have corrected the bins. Whether it is a random variable or not.
random, no, bhaiya.
Because it is not taking the quantitative data. If it is taking 1, 2, 3, 4, then. But for now, only the demonstration purpose, I have plotted that also. And if you see here you can see one my line which is approximates. This is not exact line. Okay. But this is what line approximates the age. Age is something you measure. And what you measure is a continuous variable. Correct?
Yes, bhaiya.
This is what I have plotted wrongly. This should have been histogram. Only now I have come to know. Because you see here there is no gap. 10, it is 10, 20 started. But here it is gap on the scale. Okay, which I should have avoided. But this is
Yes, yes.
happening because I have taken it as a qualitative data. Forgot it. You just give the, I just draw a line here. You see this, there are 3 types of random variables and their probability mass function I have given. What can you see? The first observation I will give that all 3 graphs are not same. They are different. Correct?
Yes, bhaiya.
And it is depending on the random variable and the probability with it taking the variable. So actually I will tell you the PMF, if you know the PMF, this is what is called the probability distribution. What is distribution means? You will divide, correct? You will
Yes,
give
bhaiya.
something. You will give someone, if I have suppose 10 packets, I need to give to the only 5 students.
Two,
Okay?
two, two.
Yes, this is the first way. I can give
Yes.
2 to all. I can give first student, which is my favorite one. I will give him 3 biscuit packets. Another one I will give the half biscuit packet. Another I will give half. Another one I will give only 1 biscuit packet. Remaining one I will not give any packet. I will give 0. Okay. Or what I can give only one person I will give 5 packets. All 4 I will give 0 packets. This is what I am distributing. Correct? Are you getting my point? Distribution.
Yes.
So now here
Yes.
I am distributing, but what I am distributing? I am distributing the probability. So for this value, I am asking, what is the value you will distribute? I said 0.25. How I got this number? Because based on some survey I have did, I got collected the data, then I analyzed it. I come to know that this is the my probability. Then I come the another one. What is probability will give to the 4? I said it is 5%. So it is only 0.05. How? Because I have some data in it. Okay. Now here a person asked me, what is probability you will give for 3? What is probability? that this function, if I roll a die, you will get a number 3. This is, I know, this is only 1 by 6.
1 by 6.
So I have given distributed it equally. So for your sake of purpose, this is something not defined function, because this is data I have hypothetically made. But the die, this is what called as a uniform distribution. Okay, this is not exact, but somewhat really near to the normal distribution. And if you check the icon of our group, WhatsApp group, that is exactly the normal distribution. Normal distribution is much celebrated distribution in the history of probability. Okay, so this is what probability distribution, you come to know.
Yes.
Because PMF is only for the variables, the probability distribution, it is not called, it is called PMFs. So if you know the PMF, that means you know the probability distribution. If you know the PDF, in case of continuous random variable, that means you know the probability distribution. So this is what intuitive definition. We are not giving here definition which is mathematically correct, but now you have got some idea about what is probability distribution. Are you clear up to here? Any doubts?
Yes, I know.
Yes, I hope that others also, those who are watching, might be clear. Now we will come to the one important point. Before, actually we should have discussed this before the random variables, but if you want to know the distribution more appropriately, then you should know the probability. Probability is important, but also another two more important characteristics of that distribution. One is the expected value of random variable. Okay, have you learned about it?
Yes, Bhaiya.
Expected value of random variable. So what is the expected value of random variable? Now here, first I will give you one small example. Yes, if you know, you can explain what is the expected value of
No,
random.
Bhaiya, only meaning I know.
Oh, yes, you can share.
Meaning means we have to tell discrete random variable is also called expected value of random number, na? Both are the same, but here only mentioned you have to we can't be measure fail, only success. We have to add only success, na?
No, see, expected value of random variable means on an average, what is the value that random variable will take? Okay, that is, we are carrying the assumptions. So now you leave this example. This is very complicated example. I will give you one small example. There is coin toss. What are the outcomes, possible outcomes?
Head or tail.
We will now convert it into the random variable 0 and 1. What is the probability it will take the probability head or 0?
1 by 2.
0.5.
0.5. 0.5.
1.5 means, okay, this much you know about the random variable and probability mass function. You come to know. Now I am having another problem. What I'm saying, this is a theoretical or before you go into the experiment. Now I really took a coin. Okay, I really took a coin, tossed it for 1,000 times. Okay, now I'm recording. Each time I'm recording, so I will start recording. So I will take here a random variable called coin toss. My Excel file, you suppose this is my Excel file, and I will start recording. First coin, suppose it is head, I will take 1. Suppose it is tail, I will take 0. So again I got head, I will take 1. Again I got tail, 0. I got now continuously 3 tails, 0, 0, 0. Then I got head, 1. Okay. First time I took 1, 2, 3, 4, 5, 6, 7, 8. 8 times only I did this. Now if I take the mean of this coin toss variable, mean means average in our Excel file. What will be the average? What will be the average? How to calculate the average of coin toss?
8 over 3 by 8, na?
Yes. So I will add up all the sums and I will come 3 by 8. Okay.
Yes.
Again, I did it for 10 times. That time I got 1, 1, 1, 1, 0, 0, 0, 0, 1, 0. Okay. What is the, this is my 10 time. Again, I did 10 times. What is the average?
5 by 10. 5 by 10 means 1 by 2.
Can I say 1 by 2?
Yes.
So now what I am saying, if I am doing coin toss for large number of time, suppose I did for 5,000 time, if I did my times for 1 lakh time, 10 lakh time, what can I say about this average? What will be its average?
Expected value, no?
That is what the expected value of random variable. How to calculate that? Expected value of random variable is very simple.
Average.
What values it is taking? 0 and 1. So what you do, simply multiply your value with probability with which take it value. So 0, it takes with probability 0.5. What is probability? So what is 0.5 into 0? It is 0. What is 0.5 into 1? It is 0.5. So that's why the expected value of this random variable is 0.5, which is 1 by 2. So if you take a coin which is fair, if you toss for 1,000 times or 10,000 times, and if you take the average, you should get the very close value to 0.5 or exactly 0.5. Many times what happens, you will get 0.499 or you will get 0.50001. So these are nearby to the 0.5, but you can say that if you do sufficiently large amount time like 1 lakh time, then you will get 0.5. Got the idea? What is the idea? Got the idea? What is the expected value of random variable? Yes. Now, can you calculate the expected value for my this random variable education, which takes the values 1, 0, 1, 2, 3, 4, 5, and 6 with probability 25, 25, 25, 10, 5, 5, 5. How you are going to calculate this?
That
0
multiple
into probability of education, which it takes 1 into 0.25, 2 into 0.25, 3 into 10.10, 4 into 0.05, 5 into 0.05, 6 into 0.05. That's what I have calculated in Excel. So if you add up this all values, you will get 1.8. So that means what? If you take
value.
Yes, expected, which means in real life what? If you go and check, suppose this is I have calculated for a village with 10,000 population. If I go and collect the data for 9,000 people in that village, and if I take the average of these values, so what will value come? Suppose someone is doctorate, someone is primary, someone is illiterate, someone is, so you are able to see here, isn't it? So
yes,
like that, I will take one for suppose it is primary level, so it is around 3. What is the average? Now average here is 10 by 4, which is 2.5. But if you do it for 9,000 people randomly, if you select, if you take, it should come very close to the 1.8. This is what is expected value, or in simple terms you can say it is the average of random variable. Okay?
Yes, bhaiya.
Got point?
Yes.
Now another is here, which is called the variance of random variable. This is what we have learned in descriptive statistics. Now you see how we are using the descriptive statistics actually in the probability theory, which is inferential statistics. That's why we have learned these terms earlier. Okay? So now this is the formula. You need not to remember. This is little bit complicated calculations, but now softwares are available which will calculate this for you. If you go in Excel, if you calculate, give this data to them, they will calculate. Or there is SPSS or there is Python. So need not to be worried. But here you have some understanding that what is the variance. How we have calculated the variance for the variable without probability. What we have did, we have calculated the mean or mu. This is the population mean. What is the x bar? That is the sample mean, correct?
Yes.
This is population mean, this is sample mean. So from the population mean, what we have did, suppose we have calculated the mean, I will do here for your sake. Now suppose we have only three values, 1, 2 and 3. Okay, I will take one more for the sake of calculations is 2. Okay, so what is the average? It is 8 by 4, which is equal to 2. Okay, so my average is mean is 2. Then what I will do, I will take the square difference. I will now change the color. So now what I will do, 2 minus 1 whole square plus 2 minus 2 whole square, 3 minus 2 whole square, 2 minus 2 whole square. What it will come? So now I will just erase this. It is equal to 1 square, 0 square, 1 square, 0 square. So I will, if I add up, this is 1 plus 1 is equal to 2. So what is my variance? It is 2. This is how we have calculated for normally variable or random variable. Okay.
Yes.
Now when it comes to the random variable, and we are now calculating the variance of this random variable or distribution, rather than random variable, we will say it's a distribution. Okay, words are not important. Then what you need to do, it is given by this formula. X is your observation minus mu, which is your actually expected value, okay, into the probability which it takes x. This is a whole square. So here I have written the formula for you. It is expected value of x minus x whole square into probability of x. Okay, with which I will calculate. No need to go into the depth. This is what I have did in Excel. So you can plug the values here. Suppose now it takes the value. So I will calculate this into this. With square, it is 0. So this is 1. So expected value is my 1.8. So 1.8 minus 0.25 whole square I did. So some calculations are there. And now I will get the values, and variance is 2.76. Okay, don't worry much about this, but this is what you need to define about the variance of random variable. Okay.
Yes, sir.
So now we will come to the uniform distribution. Right now we will enter into, so I assured you we will cover today two random variable, two distributions, which is uniform and binomial. So what is uniform distribution? Can you tell me with this information I have given on the screen?
All equally distribution means same.
But now you need to talk in the statistical terms. Okay. Uniform distribution is for what? Random variable, correct?
Yes.
There is one random variable we are talking about. What is its distribution? What is our random variable? Number on die. This is our random variable, correct? And we are asking that what is the probability distribution? What is distribution? Probability distribution of this random variable. So we are saying that if this random variable takes the value x, any x value, takes the random variable with probability 1 by n. What is n? This is your total values. How many values are there? 1, 2, 3, 4, 5, 6. So In this case, it will become 1 by 6. So
6.
any x, what is possible x here?
1, 2, 3, 4, 5, or 6 also.
6. So 1 to 6, whatever value plug here, so probability of 1 is equal to 1 by
1
6.
by 6.
Probability of 2, 1 by
1
6.
by
Probability of 3, 1 by 6. This is what uniform distribution. Whatever value you plug here, it will give 1 by n. This is generalized formula. Why generalized? Now here there are 6 values. What is in coin toss? There are only 2 outcomes.
Oh,
Okay. So what it will become? Probability of x is equal to 1 by 2.
1 by 2.
So whatever x you plug, 0, 1 by 2, 1, 1 by 2, head 1 by 2, tail 1 by 2. Okay.
Yes.
This is what uniform distribution, right?
Yes, bhaiya.
Why we need to learn this distribution? Why? What is the need of this distribution? Okay. We will come to that point with next slide. Next slide, I am having a problem for you. Okay. You need to solve. The problem is this. This is my crowd, correct?
Yes.
Able to see me. I am here in this crowd. Okay. So
Okay.
now I will do one thing. Are you able to see now?
Yes.
Here I am available. This is me. Okay.
Yes.
I want to ask you that one minute. Okay. So now I want to ask you that what is the probability that the randomly selected person from this, I am selecting a person randomly from this. Okay. What is probability that I will select Mayur, which is here? What is the probability? This is what the problem. This is what real life problem. Are you getting my point?
Yes, bhaiya.
This is what the real life problem. If you solve this problem, you will also come to know about some sampling methods.
Only one na bhaiya. Overall,
What is the distribution here? What is probability of selecting this person? 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 What is the probability?
uniformly.
It is 1 divided by n. Okay.
Yes.
Now
Yes.
if I tell you with some artificial intelligence formula, I calculated that here there are 10,000 people,
1 by 10,000.
because you know that this is uniform distribution. This is what you know, right?
Yes.
This is the problem of uniform distribution. If you don't know this, you will not able to calculate. Correct? If you know
Yes.
that this is uniform distribution, that's why the probability of selecting Mayur is 1 divided by 10,000, which is 0.000, one more zero, 0.01. Very, very. How we are using this in sampling distributions? We are going into the village and we are selecting a person randomly. And we are saying that with that method, we are giving equal probability to selecting any household. Got my point? That is uniform distribution. That's why we are selecting the random sampling method that we will learn later also. Okay? Got my point?
Yes.
How
Yes,
in
bhaiya.
real life we are using this?
Yes, bhaiya.
Yes. So now we will give you the another problem which is coming from the coin toss. We have only 10 minutes left. But for the exam, what are the probability distributions you have?
Binomial is also I have. So binomial condition necessary for binomial distribution, normal distribution,
Are having
Poisson
even Poisson
Poisson
distribution.
distribution. Hmm.
You
Bernoulli.
need to study that on your own, but we will today we will come to the only binomial distribution because see we are not studying for the exams here. Okay, because
Okay, way out.
we want you to learn because I have also learned statistics there QTMR, but I don't remember anything because I have not learned in this way that what is the real life example. Tomorrow or day after you will have example that after that you will forget all the formulas, you will go for holiday, and then again when you come back you will have zero knowledge. So that's why we are important, we are giving much more time that how to study about binomial distribution. Okay, so now here I am having
Mhm.
three questions for you. You tossed a coin. What is probability that you will get head?
1/2, na?
By two, correct?
0.5.
Okay, so now here you tossed a coin thrice. Three times you have tossed a coin. What is the probability that getting exactly two heads?
You draw the coin thrice.
What is the sample space? If you toss a coin thrice, what is the sample space? What are the possible outcomes? What you will get?
Head, tail.
Head, head, head. Then you will get head, head, tail. Then you get head,
Head,
tail,
tail,
tail. Then
tail.
you will get tail, tail, tail. Then you will get tail, head, head. Okay. Then you get tail, tail, and head. Correct? Only
Yes,
these
Vaya.
six. How we are calculating this?
Probably.
2 to the power 3. Actually, it should come the 8. Some we are missing something
Ah, it,
here.
ah,
It is TTH.
TTH, TTH,
Oh, sorry,
double
3.
TH.
Uh, double
Ah, okay,
TTH also. Okay,
TH.
whatever. Suppose this is okay. No, we are not interested in that. How to calculate that? So what we are saying that we are calculating exactly two heads. Suppose this is our sample space. Okay. What is probably here? Exactly two heads. What are the your favorable outcomes? I will
One,
change
two,
color. This one and this one. Correct?
two. Yes,
So what is the probability of getting exactly two heads? It is
2/8.
2 by 6.
Two
Where
by.
is the 6?
Hmm.
6 only, no?
Ah,
So it is equal to 1
yes,
by 3. Okay.
yes.
Now I am having another problem for you. I don't have solution. That's why I'm asking you. What is probability if I tossed a coin 2000 times? Okay. 2000. What is probability of getting exactly 100 heads? Can you able to calculate this?
I am searching formula.
Okay, no need to search formula. See here what how the binomial distribution have came. Correct. For that we need to now you forget about this problem. We will come only up to this problem. We have tossed coin only once. So now we will coin some words for head and tail. Earlier you were saying head and tail. Now I will say that if I get head, that is my success. If I get tail, I
Fail.
will get
Ah, yes.
failure.
Hmm.
Okay. Any point in time, only two values are possible. Either I will succeed, I
Success
will
or failure.
fail.
Fail.
I will point here for this. What is probability of success?
1,
1 by.
1/2.
What is probability of failure?
1/2.
So now this probability, I will say success probability is P, failure probability is Q. Okay.
Yes.
So now I want to get this problem with this information. So what is I have tossed a coin twice, 1, 2, 3. I don't know what will happen here. Success or failure, success or failure, success or failure. I want to get only exactly 2 heads. Okay. What are the possible ways I can get 2 heads? Either here I will get head, head, tail, or tail, head, head. Which were we missing was like this: head, tail, head. Correct?
Yes.
So this is the actually problem. If you remember, we have studied permutations and combinations. We have 3 spaces, 3 empty space. We want only choose 2. In how many ways I can choose? 3 choose 2. Okay.
Yes. Yes.
Another problem is that what is probability of getting this outcome? Head, head, tail. What is probability I will get head, 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 tail? It is success. P, P, Q,
Q.
P into P into Q. Okay. So it is equal to
Yes.
1 by 2 into 1 by 2 into 1 by 2, which is 1 by 8. Because we have tried this, there will be 8 total outcomes. So getting any one, this also will be 1 by 8. This will be also 1 by 8. Here it is only example you will get where the probability of success and failure is same. What if I change probability of success is 1 by 4 and probability of failure is 3 by 4? What will be our output? It will be P
Change.
times Q, which will be 1 by 4 into 1 by 4 into 3 by 4, which is equal to 3 by 64. Okay. If I change the values, it will change. Don't be sure that only this will be sure. Okay. This is
Yes.
not case. Now this is what generalized in formula. What person did? One wise person like you, he noticed this and he generalized that how many ways you can do. There are totally n number of times you are going to do this. How many times you want success? This is I'm saying 2 times success only. So it is he said that n choose r. This many times only you can choose. Either we have said first 2, then failure, first failure, then 2 success, or success, failure, success. These 2 times. Only n choose r times you can do. But what is the probability of getting individually that success is? Probability of r. This is what success we want
R means
into failure n minus r. What formula you want. This is what formula of binomial distribution, correct?
yes.
So what is this? Now we will plug this value to get the answer. Coin thrice, 2 heads. We have calculated it should come around the, I think it is 3 by 8, somewhere, we will check. What is probability? This is 3 choose 2 into probability. What is the probability of success? This is P, 1 by 2
Mm.
raised to how many success we want? 2
2.
into what is probability of failure? 1 by 2 into n minus r. What is n? This is 3 minus 2. Correct? 2 success, 1 failure. This is what we want. Correct? 2
Yes.
success, 1 failure. That's why success raised to success time, failure probability raised to failure times. Correct? This 2 comes should 3. Now what? 3 choose 2. We have seen that the formula is that I think n factorial divided by n factorial into n minus, sorry, r factorial into
1.
n minus r factorial. Okay. This is 3 factorial into 2 factorial into 1 factorial. It is 3 into 2 factorial. 1 factorial is 1. 2 factorial is in cancel 2 factorial. Remaining 3. That's why 3 choose 2 is 3. Okay. This is I have calculated. You can try on your own.
Yes.
Into 1.2 square, what is it? It's 1 by 4 into 1 by 2. So what it is giving? 3 by 8. This is what we are expecting. Correct?
Yes.
So for now, you come to know this is the formula for binomial distribution. So now you are coming to the understanding the use of distribution. Getting my point?
Yes, bhai.
If we know the distribution, this is what we don't know what will happen 2000 times. But because of distribution, we know we are able to calculate this without even
Okay.
doing some calculations. Correct? Here, we don't know what is exactly the data. But once we know the distribution of this population, we will easily calculate the probability of getting a person. Got my point?
Yes.
That's why probability distributions are important, because once you know, this is for the binomial distribution formula in case if I forgot. Here they have used the R, X instead of R, where I choose the N, choose R. This is another notation only, notation change. This is what they have written here. N choose X, they have written here. Okay. So if you want, you can take the screenshot, or otherwise I'm
Okay.
sharing this video with you also.
I
So it
took
is
screenshot, bhai.
success into the probability of success raised to number of success you want, failure into number of failure you want. What is failure you want? From total minus success. It is, and for this formula is that n factorial divided by n minus r factorial into r factorial, p raised to r into n minus r. And this is the explanation what it here given. Okay, so I will just clear. Now only one concluding remark before we end. See, this is a very, very powerful distribution. What are the important things before using the binomial distribution you should know? Your experiment should have only two possible outcomes. What are they? Success
Failure or
and
failure.
failure. The events, two events should be independent. Suppose you tossed a coin. The coin is something magical coin. If you get heads, the second toss will always get heads. That is dependent on first choice. Then you cannot use the binomial distribution, because what will happen? Once you get the head, the probabilities will start changing, because next for sure you will get head. So the probability will become 1 for another head. So problem will come. Got my point? So the
Yes.
first event, like tossing coin 200 times, if I get head in first toss, I don't know what I will get in second toss. Correct? It can be a
Yes.
probability with 1 by 2 it will get head, with 1 by 2 it will get tail. Right? In that case only you can use the binomial distribution. These two conditions should be satisfied. Where can you use this? You can use anywhere, at least anywhere where you can define these conditions. Okay? So now I will take
Yes.
you here. Okay? This is my uniform distribution. Correct?
Yes.
This is my uniform distribution. But I can model this as a binomial distribution. How? Okay? I will say if I get a even number, it is my success. Okay? That's why I was telling always this is sample space.
4, 6.
How to define events is important. Now I defined my event. If I get even number, I will get success. If I get odd number, I will get failure. Now I want to count the possibility of success. What is the probability of success, which we say P? What is probability of P here?
3 by 6.
3 by 6, which is 1 by 2. What is the probability of I will get failure?
1 by 2.
1 by 2. Got my point? Now I'm asking, the question is that if I roll a die for 2000 times, what is the probability that exactly 100 times I will get the even number? Okay. Now I changed my distribution to the
binomial distribution.
binomial distribution, because with even this my uniform distribution, I'm not able to calculate this. I need to use some formulas like
Yes.
the 2000 choose 100, and then I need to calculate what will be there. Very complicated. But now I have modeled this as a binomial distribution, and it becomes very, very simple. What I need to do, how many success I want? 2000 choose 100
100
into
times.
what is probability of success? 1 by 2 raised to what? How many success I want? 100 into what is
100.
probability of failure? 1 by 2. How many failures I want? 1900. I plug these values, calculate, and you will get your answer immediately.
Yes.
Okay. So this is what the power of distribution.
Binomial.
Distribution, not only binomial, there are many distributions we will do. So what we are interested in now, that's what I will conclude here. This is what our population, you might have seen the stars. The first example, first session, if you have attended, I have given the stars example. This is our population, total population. I want to know the distribution. Here I know distribution because they are very evenly spread. But what if there are so many people here, there are few people here? So this distribution is not correct.
Yes.
In that case, I'm interested in knowing what is the distribution of population, so that I can have some that. Okay. Up to here, everything is clear.
Yes, Bhaiya.
So yes, today we have covered a very fundamental concepts of
Probability distribution.
probability distribution. We have also covered the probability mass function. We have covered the
Random.
probability. So
Yes.
yes, random variable also. So once you know a random variable, then only you can know the other things. Okay. So I
Yes,
hope
Bhaiya.
that this will help you in your personal life, in your personal studies also.
Yes, Bhaiya. Yes.
Yes. So thank you for now. Today we will close now. Thank you so
Okay.
much,
Thank you, Bhaiya.
and
Bye.
good
Good
night.
night. Thank
Yes.